In 8.3, we're going to be talking about the graphs of rational functions. Now, we've already seen a couple of graphs, and you guys have done a couple by hand with the t-shirt function and also with the problem about the soup cans. So this is just an extension of what we've been doing. If I have the problem y equals 6 over x squared plus 1, it's a rational function because it's got division. We've got an x in the denominator. And if I want to graph this guy, the fastest way to take a peek at what it looks like is just to use your calculator. So we're going to go into our y equals. We're going to plug in 6 divided by. Now, you have to make sure to put parentheses around the x squared plus 1, because if you don't, it's just going to divide 6 divided by x squared and then add 1 onto that total. So I put parentheses around the bottom of the fraction, and now if I hit graph on just a standard -10 to 10 window, I get a picture of what this function looks like. So I'm going to use my xy table just to verify how big my points are going to be. When I look at my xy table, I see that at 0, I get 6. Now, this makes sense because when I plug in 0 squared is 0, plus 1 is 1, and then 6 divided by 1 is 6. So obviously when I plug in 0, I get out 6. When I graph this by hand, I'm just going to do a sketch. So I'm going to throw down my axes. I know I go over 0, up 1, 2, 3, 4, 5, 6, and put a point. And then if I look on my graphing calculator, I'm going to just take a couple other points to make it look accurate. So I've got -1, 3, and 1, 3. So I go over 1, up 3, back 1, up 3. And then I can tell that this is a curve. And it seems to me like the x-axis is a horizontal asymptote. Now, just to double check that in my xy table, I can look into my table set, started at 0 and go by 10s, let's say. And now if I go into my table, I see that as I scroll down, sure enough, we're getting e to the -4 is 0.0004. And so we're getting closer and closer to 0, but we're never actually getting to 0. It's just getting smaller and smaller. So that is a horizontal asymptote for us. So in this problem, we have a horizontal asymptote. I'm just write asimp for asymptote for right now, at y equals 0. On this problem, there is no vertical asymptote, and if I were asked to state the domain and the range, right now, the domain is all real numbers. So I'm going to put the double R for all real numbers there, because x's can be negative, they can be positive, they can be 0, they're all giving me outputs. The range for this problem, since my outputs, my y values are all above the x-axis, my range is y is greater than 0 because I'm not achieving any negative or 0 outputs. Now, if I want to take a look at another rational function, for example 2, by the way, these are examples straight out of your textbook, so you can take a peek there too if you want. I get 2x squared over x squared minus 9, and this is equal to y. Now, to begin with, I'm going to go to my graphing calculator again. I'm going to go into my y equals, and I'm going to plug in 2x squared divided by, and I'm going to put parentheses around the bottom of my fraction just like I did before, so x squared minus 9. Now, when I graph this, I get a branch of the hyperbola here, I get a branch of the hyperbola, and another branch. So this has 3 branches. Now, it looks like I've got a horizontal asymptote here, and it looks like I've got 2 vertical asymptotes. So let's investigate why we're getting those. Now, I see x squared minus 9, and I recognize that as a difference of squares, so I'm going to factor it as x plus 3 times x minus 3. Okay. We know that we can't divide by 0, so if x is equal to -3 or if x is equal to 3, those should give me errors. Now, when I look at my graphing calculator, oh man, I'm getting close to my time limit. We'll see how far we can make it. If I go back to table set, I start at 0 and count by 1s. And now I go into my table. Sure enough, at -3 I get an error, and at 3 I also get an error. So those are going to be my vertical asymptotes. And then if I go into my table set and I see what happens as x gets really big, I see that it keeps getting closer and closer to 2. That makes me think on the graph that my horizontal asymptote is probably at 2. So when I go to graph this, I know that at 3 I've got a vertical asymptote. At -3, I've got another vertical asymptote. And at 2, I've got a horizontal asymptote. And then I can draw my graph in. I've got a branch here, I've got a branch here, and a third branch up in this corner.